biologics are very important in the age of modern medicine. In 2012, 8 out of the 12 top-selling medicines were biologics, used to treat everything from arthritis to Crohn's to cancer. That being said, what are they? After browsing the internet for a bit, I found that biologics are drugs produced not by chemical reactions, but with the use of living organisms. These cells are modified using recombinant DNA technology to produce the drug.
This all sounded a bit complicated, so we went down to Keck Graduate Institute in Claremont for some more information on this technology and the industry as a whole. As a prominent life science-oriented graduate school looking to establish their new Masters of Engineering in Biopharmaceutical Processing, this was the perfect place to go. Here we were able to talk to students about their collaboration with industry partners and get a first-hand look at some of the research that is done. Currently, most biologics are produced in a fashion known to chemical engineers as a fed batch process. Specific to this case, this means that a certain number of organisms are loaded in at the beginning, the batch part, and everything that is needed to keep these organisms happy are continuously fed to the bioreactor in order to stimulate them to multiply as efficiently as possible before the medicine is extracted and purified. After drug discovery, most of the research goes into providing the optimal conditions. This research is usually done in containers ranging from 500 milliliters to 2 liters. It's done this way because full-scale production is very costly. Once ready for full-scale production, this is where the chemical engineer steps in. Their primary job is to take data from the small 1 to 2 liter processes and make it work on scales ranging from 2,000 to 500,000 liters. The chemical engineer, or more likely engineers, are responsible for making sure that everything stays consistent. This may sometimes be as easy as simply putting in more of everything, or as hard as designing a whole bioreactor to fit the specific needs. After all this is said and done, the engineer must be able to prove that, with their proposed process, the drug will come out pure, free of any contaminants, to organizations such as the FDA. This is arguably one of the most important steps. For example, several biologics are produced using modified E. coli. Though most strains of E. coli are harmless, others can cause infections, diarrhea, or pneumonia, things one should not get from their medicine.
There are jobs galore. In biopharmaceuticals alone, the growth in employer demand for engineers with this training has nearly doubled in the last 6 years and is sure to continue growing. Lastly, though the work may sound tough, it is very important. These medicines have the power to save lives, and if it weren't for chemical engineers, it would not be possible for the industry to exist in its current form. I heard it best put, engineers are the unsung heroes of the medical field.
Not to mention, it pays well. To close, I'd like to give an extra special thank you to the team at KGI for all the assistance in making this video, and the National American Institute of Chemical Engineering for hosting this competition.